Okay, so let me return to the question that you asked a bit earlier about how do I find actually volume if I don't want to know about determinants. Well, so let's have another look at the volume. Okay? So let's say that I have three vectors. Let me put them this way, A, B, and C. And let's try to see how else I could think about the volume of this box. Okay? So probably you know that the volume of a parallelepiped is the area of a base times the height. Okay? So, sorry, the volume is the area of a base times the height. How do we do that in practice? Well, what's the area of a base? So the base is a parallelogram in space with sides B and C. How do we find the area of a parallelogram in space? Well, we just discovered that. We can do it by taking the cross product. So the area of a base, well, we take the cross product of B and C. That's not quite it, because this is a vector. We would like a number. Well, we take its length. Okay? That's pretty good. What about the height? Well, the height is going to be the component of A in the direction that's perpendicular to the base. So let's take a direction that's perpendicular to the base. Let's call that n, a unit vector in that direction. Then we can get the height by taking A dot n. That's what we saw at the beginning of class. Okay, that A dot n will tell me how much A goes in the direction of n. Okay, are you still with me? Okay, let's keep going. So let's think about this vector n. How do I get it? Well, I can get it by actually using cross product as well. Because I said the direction perpendicular to two vectors I can get by taking the cross product and looking at that direction. So this is still B cross C length. And this one is, so I claim, I should do an aside here, n can be obtained by taking B cross C. Well, that points in the right direction, but it's not a unit vector. How do I get a unit vector? I divide by the length. Thanks. So I take B cross C, and I divide by length B cross C. Well, now I can probably simplify between these two guys. And so what I will get oops. It's going to be the last thing for today. What I get out of this is that my volume equals A dot product with the vector B cross C. And of course, I have to be careful in which order I do it. If I do it the other way around, A dot B, I get a number. I cannot cross that. So I mean, I really have to do the cross product first. I get a new vector, and then I dot product. Okay, so the fact is that the determinant of A, B, C is equal to this so-called triple product. Well, that looks good geometrically. Let's try to check whether it makes sense with the formulas. Just one small thing. So we saw the determinant is A1 times determinant B2, B3, C2, C3, minus A2 times something, plus A3 times something. I'll let you fill in the numbers. Okay, that's this guy. What about this guy? Well, dot product. We take the first component of A, that's A1. We multiply by the first component of B cross C. What's the first component of B cross C? Well, it's this determinant B2, B3, C2, C3. right? If you put B and C instead of A and B into there, you will get that the I component is this guy, plus A2 times the second component, which is minus some determinant, plus A3 times the third component, which is again a determinant. And you can check to get exactly the same expression. So everything is fine. There's no contradiction in math just yet. Okay?